My name is Jonathan Asher. I'm the Portfolio Director for CATIA Construction. So I manage the portfolio of roles and applications that are available on the 3DEXPERIENCE platform from the CATIA brand. CATIA brand is a CAD package. It's a CAD software. It's one of the most famous CAD solutions, I'd say, for parametric design. We have a rich history, and our motto is shape the world we live in. Why do we shape the world we live in? How do we shape the world we live in? Well, CATIA is used to design 90% of the cars that are on the roads today. Airplanes, if you rode over here on a Boeing, or if you flew here, if you're not from here, I flew on a Boeing, I think. That's designed in CATIA. Airbus uses CATIA. We have an aviation history. Dassault Systemes came from Dassault Aviation, which is an airplane company. And so we have a different approach to different industries based on what's specific to them. And recently, we've transitioned from an approach to architecture, engineering, and construction to a more holistic approach of construction, cities, and territories. Construction, that includes architecture, that includes engineering. Cities, that's more the administrative regulatory layer. And then territories is how does that all come together? From the AEC perspective, we have a long history. We've started in our parallels in the development. Do I have a laser? Yeah. The parallels in the industry match the parallels of Dassault's evolution over time. So as the industry was still manually drafting, Dassault as a company was a couple of steps ahead, developing 3D design with the 3D digital mockup. In CATIA V4 with the Bilbao Museum from Frank Gehry, we were doing the digital mock-up for airplanes, Boeing. And then we're getting into augmented design, cognitive augmented design, and 3D PLM. We like to say now that we're moving beyond PLM, we're moving to a platform, this 3DEXPERIENCE platform, which is the next step in PLM, making a platform that is for business operations. Not just product lifecycle management, but it's an entire operations, a system of operations for a business, for an enterprise. So, BIM. I like to think BIM is dead too. I'd like to extend this and say that BIM is not efficient. BIM is not a solution to the construction problem because it is product centric. I'm sorry, we're talking about products with JM, but a building isn't a product, it's an experience for an end user. And the construction isn't a product, it's a process. And so BIM as a product-centric approach is incomplete, and we'd like to say, well, at least up until today, I was pushing building experience modeling because it's a process that happens within the context of a city. But given the current discussion that's been happening today, I think it might be more appropriate to say that BIM isn't building experience modeling because that's just modeling is kind of it's not going far enough. It might actually be more appropriate to say this is building experience manufacturing. We're manufacturing buildings to produce an experience. So next time you see this slide, it might say building information modeling to building experience manufacturing. So I'm the portfolio director for CATIA. This is our offering. We've talked philosophically today about what is BIM, what is construction about. Well, with CATIA, this is the nitty-gritty. This is what we use, the roles that we use to produce a building information model, a building experience model. I'm going to start by talking about the X apps. X apps are a new breed of applications that are available on the 3DEXPERIENCE platform. They run on the cloud in a web browser. And the driving factor for this is that it's a mobile-first application. It's available anywhere, on any device, at any time. And these are innovative new applications that allow designers to explore design variation and come up with new and interesting, game-changing designs to products and projects. They're almost all running. Okay, they're good. Here's a look at a couple of the X applications that are available today. There's 3DEXPERIENCE City in the upper left. That's a GIS application, essentially a GIS application that allows you to aggregate your big data into one environment. for design review or for project approvals and just a large big data environment. XDesign is similar to SolidWorks. It's developed initially by the SolidWorks team for web modeling solid parts online. XShape is a subdivision surface modeler, and XGenerative Design is a generative modeling application to do parametric computational design. And the thing about all of these is that they all run on the 3D. They all run on a dashboard in a web page. XGenerative Design in particular has been focused initially on architects, engineers, fabricators. I didn't give my full introduction. I'm an architect by training, and I tend to speak more of a design talk first. But I've also been an engineer. I came from, previous to Dassault, I was working at Zaner in Kansas City as the director of design technology, overseeing the standardization of CATIA and automation for custom metal facades. It's a specialty facade contractor based in Kansas City. So I've been an engineer and worked in construction. XGenerative Design, we'll go straight into it. As you see, if you're familiar with Grasshopper or other computational design softwares, it has a similar graphical scripting interface, but you can also model in the 3D interface as well. This model that we're looking at here was a product of a hackathon that we organized a couple of months ago in Milan. And this project used XGenerative Design as an urban design tool to imagine how to redevelop certain parts of the city in Milan, from the old Parco Sempione district to the new City Life district. And they created then this generative urban template, urban city block template that was producing different types of building typologies based on the data around it. So it's this here we see XGenerative Design embedded in 3DEXPERIENCE City, where it's taking data from the city environment, manipulating it to produce different types of block configurations, and then putting it back into City so that it could be reviewed by the different stakeholders. So that's XGenerative Design, but it sits within a larger context of roles. So these are the traditional CATIA roles in app that sit in the rich client that's installed on your machine. We have roles for architectural detail design, concept building design, and civil engineering. The important thing to know, though, is that this is one platform. The 3DEXPERIENCE platform is a common data environment with a common data model, so that models that are produced in XGenerative Design or in other applications in CATIA, they can be reused for simulation, they can be reused for process planning, in construction simulations, the 4D, 5D, however far you want to go. I say, I don't put the slide in here, but I think it stops at 10D. And you can count all the way up to 10D. 10D ending with the full lean design for manufacturing and assembly. Our data model, we are IFC compliant, so there's IFC inside. And what does that mean? Well, that the product structure of a building assembly starts with the site, goes down to the building, the story, and then within that, you have different types of objects. For example, the curtain wall. This is a functionality that an architect is going to enjoy, because they can quickly pattern a facade and play with the different parameters to change mullion height or mullion thickness, mullion depth, color opacity. And we talk a lot about capturing knowledge and know-how. And the great thing about this is once you've done one pattern or one facade that you like, you can quickly match that, replicate it from one face to another, capturing the pattern, capturing the knowledge, and passing it on to different faces. There's also structures modeling. So this is building structures application, and we include accelerators so that you can design a conceptual level of detail model in just a couple of clicks. Here we're going from point to point. Before we were doing above and below, and this it's all based on the grid. You can also do live rendering, where we're animating cameras. We're going to do some sun shadow studies. What these videos are showing is it's the design side. I'm going to start with design, start talking with architecture. But what's important here is that we're linking a design software, a design application, to a manufacturing application. Because CATIA's strong suit is in manufacturing. CATIA's PLM, and I'm surprised I haven't heard it yet, but the next interesting or industry appropriate acronym that I haven't heard yet today is BLM, the Building Lifecycle Management. But what is that used for? Well, once you get to a certain level of detail, you can take that, what we call the 3D experience twin, not just the digital twin. You can take that 3D experience twin into the manufacturing realm and start building and optimizing your assemblies, optimizing your construction for either off-site construction or an optimized on-site assembly. This is the bridge then. This is a video that shows the bridge between a designer and a manufacturer, where the designer wants to model with spaces. We're going to drop a couple of spaces in there, and then we're going to associate those spaces with what we call engineering templates. And those engineering templates represent full-out fitted apartment units and assemblies. So by connecting the designer to a team of more advanced engineers, the designer can worry about the space planning and the overall configuration of a floor of a building. And then by using component-based design, they can instantiate detailed components that come from a team of more specialists. And so the specialists have captured their knowledge in a template, in a parametric template that's governed by rules, and rules of distance, rules of proximity. And then as the designer has instantiated that template and is playing with the form that controls it, well, the rules inside are going to dictate the actual configuration there, and it's all parametric. And you see that as levels of detail increase and as the complexity of these units increase, they can become more and more intelligent. Here's another example of a bathroom pod. And going one step further, you can also embed the manufacturing and assembly logic into those units as well. This is a living unit that's been fully detailed, and inside of this template, a number of rules and checks have been inserted into it, so that as the parameters change, as the width of this thing extends, we're going to get a notice that actually this unit now has exceeded the North American transportation dimensions for a flatbed truck. So the designer might have pushed the boundaries a little too far. They've taken that model one step too far. So we'll need to backtrack. But also included in that template is now all the assembly information, so that we can control the supply chain, we can control the installation, and through this is all the same data model. These are all the same objects. We're adding time, we're adding cost, and we're coordinating then schedule. And that gives you can imagine, we're giving this information, we're giving this control to the designer. So the designer knows that when they're modeling with a block of volume, they're actually modeling with an intelligent unit that is more than just geometry. This is in smart componentry. And then you can run your what-if studies, and you can find clashes and make sure that you're coordinating your geometry and your components. Extending that further, Patrick showed the still of this earlier, but you can take this extended into then the virtual design and construction approach, design for manufacturing and assembly, where you take that detailed model and working with the installers, working with the general contractor and the subtrades, you can optimize the installation and make sure that what is planned is actually executed on site. For this project, this was a project coordinated by our partners CAD Makers in Vancouver to build what was the world's tallest wood timber building. cross-laminated timber building. And through the installation site planning, they were able to reduce the superstructure erection in under, I think it was 2 months, and save 5 million Canadian dollars on a 50 million Canadian dollar project. So substantial savings, all just through coordination of installation of the superstructure. And so for us, the 3DEXPERIENCE twin is a way to manage complexity and to really to visualize with all stakeholders, visualize the direction of a project, the future, the coordination of the project.
Where I have the most fun is where I tell the system to do the job for me. And with KnowledgeWare, with EKL code, VB, it's fun. I tell the system, do this, do that. But what I'm the most impressed with is what I've done here. A 3D mock-up of the house. So from the surface of the architect, in less than 10 minutes, with a little bit of code, I got a complete 3D mock-up of the house with the code for the machine to do the job. And that is, for me, my best achievement so far.
That's a small clip from a new startup called Laco Labs in Luxembourg, who's developed an automated approach, an automated system of manufacturing single-family houses and multifamily houses as well. And what the incredible thing that Eric is saying there is he's automated everything. He's automated from an architectural surface model the creation of all of the wood framing plus the G code to run the factory. And so how does this fit then into the context of a larger project if you're doing, say, systems engineering or mechanical, electrical, or plumbing of a building? You can build models of not just the geometry, but you can also embed then the information about each piece of equipment on there as well. And we'll see a little more of that in a second, because this is one common data environment. The data for all of that components, see even the PDF of the specification for that equipment is visible on the platform. And so to go from building information modeling to building experience manufacturing, what does that mean? We're going from an operational view, which is the architectural view of a project, passing through a functional view, which is the performative aspect of each one of those components, to the organic view. The organic view of a 3DEXPERIENCE twin, which is composed of the individual componentry. What is a 3DEXPERIENCE twin from a manufacturing point of view? Here's a look at an escalator. And that escalator, it's an assembly. It's an assembly of thousands and thousands of drawings. It's an assembly of thousands and thousands of parts, but it's also an assembly with behavior. So in this case, the behavior of the part, the behavior of the product has been embedded, and the interfaces between the parts can be simulated and activated. So in this case, the elevator or the escalator, it's not just a geometric representation of a thing, of an object, but it's a living, breathing, moving organism. And in this case, this is a configuratable escalator that is connected to the shop floor. So when an order comes in for this escalator, the parameters that drive it produce a new configuration based on those parameters, and then that information gets pushed to the shop for manufacturing. And all of those drawings, because yes, there are still drawings required, not for fabrication or manufacturing, but for certification, are all produced directly from the model. What could that look like from a building perspective? Well, this is a 3DEXPERIENCE twin of a building that was done, where we see that, okay, there's the componentry, you see all the componentry, but the logical connections are in place too. You don't just have the physical connection from one object to another, but you have a logical engineering electrical connection that reflects the relationship, there we go, and then can be further expressed and further revealed through the physical relationship from those two pieces of equipment. And again, similar to what we saw with the MEP example, because it's an object that's been purchased, the specification of it can be embedded on the 3DEXPERIENCE platform and then it can be accessed anywhere, anytime, from any device, just based on your access point, whether it's through the web or through the rich client here. And I guess that's the building side of things. I'll talk a little bit about infrastructure because we also have a number of solutions to do bridges and tunnels and roads and rails. So this is a talk about we've got for rebar and then the design of tunnels. So we have with the civil engineering role and some automation techniques, we have solutions to do the alignment design, to do the terrain modeling, to do the excavation calculations, and then to model tunnels based on specifications. So here we want to specify that the tunnel needs to be wide enough to handle 2 trucks, 4 trucks, whether it's 2-lane, 4-lane, and then automate the generation of the rings that are going to support that. In this video, I don't have the actual rebar for the rings, but this model is eventually developed further to contain all of the rebar for this as well. And I haven't shown a lot of our success stories here, but we have a large user population in China that have designed at this point thousands of kilometers of railroads. But I do want to show one example of a bridge that's been designed recently in CATIA. This is the Denzheng Bridge in Taiwan by Zaha Hadid Architects. They worked very closely with a partner called Sinotech, a local partner, to do the structural engineering and modeling of that componentry. And the beautiful thing about this project is that they've partnered with advanced manufacturers to imagine a new type of formwork that could transform, could morph itself to achieve this smooth flowing concrete up as it rises up the mast. And the former company, I forget their name, but they're located in Germany. This project, because it was on the cloud, they were able to collaborate with Sinotech, who is local on site, where Zaha Hadid was managing the surfaces, the surface design, and Sinotech then was in the same model doing all of the rebar to do. And even at this point in the project, they didn't need to model all of this rebar, but they were doing it to manage complexity and quantity so that they could get accurate quantity takeoffs, so that they could control budget, and so that they knew that when the project went to tender, they wouldn't have the contractors trying to pull a fast one over them with too big of a margin. And you see some of the detailed views of the rebar. And they've done this on more than just bridge infrastructure projects. You've all seen this project that was recently done. This was also the CATIA project from Zaha Hadid Architects in Beijing. The new Daxing International Airport, which just opened a week or two ago.